Hey everyone, and welcome to this deep dive. We're going to be looking at something that's pretty hard to wrap your head around: pressure. I mean, we all know it exists, it's everywhere, but we can't really see it, right?
Right.
So we're going to explore how engineers use this special film and some really cool software called Topaq to actually see and measure pressure. Kind of wild, right?
Yeah, pretty fascinating stuff.
So we've got a presentation that breaks down Topaq,
Yeah.
and we'll also be tapping into some expert analysis on how it's being used and, why it even matters.
We're basically giving ourselves a sixth sense for pressure, Like taking this fundamental force that's everywhere, shapes our world, and making it something we can actually see and work with.
Okay, so before we get ahead of ourselves, let's back up a bit. This pressure-sensitive film they use, where do we even start with that? How does it actually work?
Well, it's all about these microcapsules.
Like recapsuling.
Yeah, they're embedded in the film, and each of those tiny capsules is full of dye. So when you apply pressure,
Yeah.
the capsules rupture, the dye releases, and boom, you get this visual map of the pressure distribution. It's kind of like those, what are they called? Stress balls?
Oh, yeah?
The ones that change color when you squeeze them?
Right.
Yeah, this is like that, but way more sophisticated, obviously.
Wow. So the more pressure you apply, the more dye is released, and that's what makes it darker?
Exactly. But the film itself, that's just the first step.
Gotcha. So that's where Topaq comes in.
Right.
And from what I saw in the presentation, Topaq is packing some pretty amazing features like pseudo-color maps, even 3D models. It can measure pressure in these tiny little grid squares. That's incredible. What makes these features so powerful, so important?
Well, you got to think about it. In the past, engineers, they had to rely on experience and a lot of guesswork, honestly, to really understand how pressure was affecting their designs. But with Topaq, it's all quantifiable. It's data.
So it's not just like, oh, there's pressure over here.
Nope. It's like looking through a microscope, but for pressure.
Oh, I see. So instead of just seeing like a general area, now you can actually zoom in and get really precise measurements.
And that precision, that's a game changer. Imagine you're designing, let's say, a prosthetic limb. Now you can actually pinpoint the exact pressure points and use that data to make it way more comfortable, way more functional.
So it's like taking something that used to be basically a guessing game and turning it into a precise science.
Exactly. Yeah. And that's just scratching the surface. I mean, the source overview of presentation on Topaq imaging, it really dives into, all the different ways you can use this tech.
And one of those ways I saw, there's a feature called line scan. I'm a little fuzzy on that one.
Hmm?
What exactly is that?
Okay, imagine you're looking at, let's say, a car tire. You want to know the pressure distribution across the whole thing, right?
Right.
So with line scan, you can pick, like, a line, maybe along the edge of the tread.
Okay.
And then, boom, you see how the pressure changes just along that line. It's like taking a slice, a cross-section of all that pressure data.
So you can see if there are any like spikes or dips.
Exactly. Could tell you a lot about the tire design, whether there might be problems down the road.
Wow. And the software takes it even further. I saw something about graphs and charts.
Oh, yeah. It can crank those out based on the line scan data. Makes it way easier to spot trends or anything that's, out of whack.
That's slick. Now, the presentation also talked about how Topaq can be used to analyze pressure changes over like specific features on a surface. What does that actually look like, though? Practical examples.
Sure. Think of a phone screen, how it has those little raised edges around the buttons?
Yeah.
Topaq can show you exactly how the pressure changes when you press down on those edges.
So you know if a button's going to work.
Right. And not just that, it's got to be comfortable to use, too.
That's a level of detail I never would have imagined. It's like almost like seeing pressure waves traveling through the material.
It's pretty wild, right? And the cool thing is, it's not just about finding problems. Topaq can help make designs better, too. Like the source mentioned, how some engineers are using it with athletic shoes.
Oh, yeah, to improve them
Yep. They look at the pressure distribution on the soles.
as people are actually wearing the shoes.
Right, so they can see how that pressure changes when the foot hits the ground. And they use that data to adjust the cushioning, the arch support, even the tread pattern, all to make the shoe perform better, reduce injuries.
So thanks to Topaq, people could be running faster, jumping higher.
It's the possibility.
Pretty incredible. But let's shift gears for a sec. I'm curious about, the practical side of things. The source mentioned Topaq can save companies time and money. How so?
Well, think about the old way of doing things. Analyzing pressure films was all manual.
Oh,
Engineers had to measure, like, by hand, try to figure out what all the color variations meant. tedious stuff, Topaq automates so much of that.
So it's like a digital assistant, but just for pressure analysis.
Pretty much. It speeds things up, obviously less room for human error, lets engineers focus on, the more creative stuff, problem solving, that kind of thing.
Makes sense. And I remember seeing something about Topaq being able to export data in different formats, like CSV files. Why is that a big deal?
Interoperability.
Interoperability.
Engineers can take that pressure data and plug it straight into other programs, their CAD models, simulation tools, all that.
It's like a team player.
Yeah. You want that smooth workflow, using the data to make the best decisions, build the best products.
That's a perfect segue, actually, because we've talked a lot about the engineering side of Topaq, but what about its impact on, like, other fields? Anything else to add about engineering before we move on?
I think the biggest thing about Topaq is that it bridges this gap between what we can see and what we can't. We're taking this force, pressure, which was kind of a mystery, and making it, real, something we can measure, understand, and work with.
And as we've seen, that opens up a world of possibilities. Not just for engineering, but for other fields too. And those are exactly the possibilities we're going to dive into when we come back. All right, so we're back and ready to explore how Topaq is being used outside of engineering. You mentioned healthcare before, which honestly isn't something I would immediately think of when it comes to pressure analysis.
Yeah, it's not the most obvious connection.
So how is Topaq actually making a difference there?
Well, think about pressure sores.
Ah, yeah.
Big problem for patients who are bedridden or anyone who has trouble moving around, Topaq can create these pressure maps that show you exactly where the pressure's highest on the body.
So doctors and nurses can use that info to reposition patients or maybe add cushioning to those areas and hopefully prevent the sores from even forming.
Exactly. It's all about prevention. But Topaq can also help monitor, if someone already has a pressure sore, make sure it's healing right, that the pressure is distributed evenly.
That's amazing. Are there any other ways Topaq is being used in healthcare?
Oh, tons. Researchers are using it for gait analysis.
Gait analysis.
Yeah, looking at how pressure changes when people walk or run could help athletes, improve their technique, avoid injuries, even design better orthotics and prosthetics.
Wow, so Topaq is helping people move better, live more comfortably. What other fields are we talking about here?
Oh, it's all over the place, really. Manufacturing, for one. Topaq helps optimize packaging, make sure products are protected during shipping. And get this, it's even being used in the art world.
No way. Wow.
Some artists are working with pressure-sensitive materials, creating, interactive installations and sculptures, things that respond to touch.
So art that's literally powered by pressure. Who would have thought?
It's pretty cool. It shows you when you find a way to see the invisible, you can get innovation in the most unexpected places.
Absolutely. We started talking about how Topaq lets us see pressure, but it seems like it's doing way more than that.
Yeah.
It's helping us really understand pressure, harness its power and use it to improve our lives in all these amazing ways.
It's a good reminder that there's always more to learn about the world,
Yeah.
And sometimes the biggest discoveries are the ones we can't see.
Well said. Thanks for joining us on this deep dive into the world of pressure visualization. It makes you wonder, what other invisible forces will we be able to see someday?